So in the previous session we have seen about coherence, right? How to define coherence for light waves. There are two types of coherences. One is temporal coherence, so that deals with phase relation between 2 points on a wave train, on a single wave train. So temporal coherence deals with phase relation between 2 points on a single wave train. Okay, and for any wave to maintain this temporal coherence, frequency must remain constant. To have infinite time of temporal coherence, right? So tau is the coherence time, the time for which the wave remains coherent. So for this temporal coherence to have maximum value, frequency must remain constant. That is the first observation. And second one, what we are seeing is spatial coherence. It gives you the phase relation between 2 points on 2 different wave trains.
Good afternoon all. Sorry for the inconvenience.
So I have seen about other one is spatial coherence. So this deals with the phase relation between 2 points in space on 2 wave trains. So here also the graph is related to time variations of waves, but these 2 waves are in space. So 2 waves in space, and the phase relation between 2 waves in space is dealt by the spatial coherence. So examples are what? Like candlelight,
handball selections కూడా రేపు ఉదయం నిర్వహించడం జరుగుతుంది కావున
right? So the examples that we have considered are this: candlelight is not spatially coherent and not temporally coherent, whereas sunlight is spatially coherent but not temporally coherent. So for 2 waves to maintain spatial coherence, both the waves must be traveling in the same direction. So they must start from a same point on the light source. If they start from different points, they may travel in different directions. So to maintain the spatial coherence, both waves must be starting from the same point and travel in the same direction. So sunlight is an example for spatial coherence but not temporal coherence. Candlelight is not both spatially coherent and not temporally coherent. Next one is sodium lamp. It is temporally coherent but not spatially coherent. Laser is both spatially coherent and temporally coherent. So these are various examples of light sources with spatial and temporal coherences. Okay, so now we are coming towards this interference. Interference is the result of superposition of waves from 2 slits or 2 sources. So for example, I am considering light from 2 slits. I am taking 2 slits. The primary condition for observing wave optics is what is the primary condition? The wavelength must be comparable to the size of the objects involved. We have studied about ray optics like reflection, refraction, scattering, all these things we have studied using geometrical optics or ray optics. So here whatever reflection, refraction, all these processes can be explained by considering ray model of light. All these are possible when the size of the object is very large compared to the wavelength of the light. So when the size of the objects like lenses or any surfaces that we are considering here are very large compared to the wavelength of the light used. So in that case we don't need to go into the details of wave nature of light. So that is unnecessary detail. I mean, even if you consider wave nature, you can explain the reflection and refraction process clearly, but that is actually unnecessary information. You can simply explain by using ray model. Whereas to explain this interference, diffraction, polarization processes, you need to consider or you must consider the wave nature of light. So without that detail, you cannot explain this phenomenon. Okay. So interference is a result of superposition of light rays from two different sources. Okay. So what actually happens? Let's say in this room we have two windows. Okay. So when I open just one window, what is the intensity pattern on the screen? Let's say on the opposite wall. So on the opposite wall, if I open only one window, the intensity will be high on that end and intensity will be low on the other end. If I open only one window, so that is intensity pattern produced by source 1. And if I open only window 2, what happens? On this end I will have maximum intensity and it reduces when you reach the other end. And if I open both of them, what happens? I is equal to I1 plus I2. So when I open both the windows together, entire room will be illuminated uniformly. So if I open only one window, the room on that end will be illuminated more. If I open only window 2, the room on that end, other end will be illuminated more. If I open both the windows, entire room will be illuminated uniformly. So intensity is I1 plus I2, resultant intensity. Whereas here, if you consider, that means what? If I consider in terms of amplitudes, A square is equal to A1 square plus A2 square. So that is the usual phenomena that we observe in the case of bulk objects. But when the size of the object reduces to very small, in this limit, where the size of the object or size of the slit is comparable to wavelength of the light used. In that case, what happens? The pattern changes. So instead of addition of intensities, you will have addition of amplitudes. A is A1 plus A2. So that final intensity is equal to A1 plus A2 whole square. You will get a combination of cross terms. So why that happens and what is the result of addition of amplitudes instead of addition of intensities is a matter of discussion. So ఇప్పటివరకు మనం చూసినట్టు ఓన్లీ ఇంటెన్సిటీస్ యాడ్ అవుతున్నాయని చూసాము. అట్లా కాకుండా యాంప్లిట్యూడ్స్ యాడ్ అయితే ఏం జరుగుతుంది అనేది చూడాలి. అసలు యాంప్లిట్యూడ్స్ ఎందుకు యాడ్ అవ్వాలనేది చూడాలి. These are the two issues. So now we're going to see the addition of amplitudes. Let's say I'm adding two waves. Addition of two waves. If both are in same phase, if both waves superimpose in a same phase, what do I get? I get a wave with double the amplitude. Okay, and if both the waves superimpose in opposite phase, so this is called constructive interference. This is destructive interference. Opposite phase. What I get? Resultant amplitude is 0. If both are equal, addition of those two waves will give you 0 amplitude. So that is called destructive interference. So these are the two possibilities that we come across when light waves from two sources superimpose. So what are the possibilities? Let's say I am considering the midpoint. So let's say to reach this point I have three waves from slit 1, and this is also at equal distance, so I will have three waves from slit 2 as well. So this point 0 or O is at equal distance of three wavelengths, 3 lambda distance from both the slits. So what happens? Both the waves undergo constructive interference. So I will get maximum intensity. Okay. So if I go a little away from this center point, let's say I'm looking at this point. What happens? So this point may be nearly 3 waves from the slit 1, but it is a bit far away from slit 2. So you may have 3.5 waves. So from slit 1 you got a 3 wavelength distance, and from slit 2 3.5. Then what happens? You will have destructive interference. And the other point, maybe 2.5 waves, 3.5 waves. So I will have maxima, minima separated from each other. So at each step I have either maxima or minima, that process continues. So what exactly am I considering here? I am considering only either constructive interference or destructive interference. What about other possibilities? So I am looking about constructive interference. So when both are at equal distance, I have constructive interference. If there is any change, the change may not be in steps, right? So I am moving smoothly from one point to another point. So what should I expect? So from maximum intensity to zero intensity, I should have a smooth change. But what I am observing here is there is a sharp change. So మీరు ల్యాబ్లో ఇఫ్ యూ గో త్రూ దట్ ఇంటర్ఫరెన్స్ ఎక్స్పెరిమెంట్స్, the interference patterns you observe are very short. But if you see here, I mean, I'm expecting a smooth change, right? Smooth change is expected. Like from 0 phase change to 180 phase change, it is not in steps. Direct గా సడన్ గా చేంజ్ అయిపోవడం అనేది జరగదు కదండి, స్మూత్గా చేంజ్ అవుతుంది. బట్ ఎందుకని షార్ప్గా మనకి ఆ ఇంటర్ఫరెన్స్ ప్యాటర్న్స్ వస్తున్నాయి అనేది క్వశ్చన్ టు డిస్కస్. ఆ మధ్యలో వాటిని ఎందుకు వదిలేస్తున్నాం? వదిలేస్తున్నాం అనేది తర్వాత, దానికన్నా ముందు అసలు కనబడట్లేదు, ఇటుపోతున్నాయి. Why they are not visible? The simple issue is the condition. This condition plays the crucial role. The wavelength of light is comparable to the size of the object. So you are fixing a limit on the wavelength of the light used. So a limit మనం ఫిక్స్ చేసినప్పుడు ఏమవుతుంది, you are considering very short waves. So I am taking a set of sine waves. They are very short waves. So ఇలాంటి షార్ట్ వేవ్స్ సూపరింపోజ్ అయినప్పుడు what is the result? What I am seeing is either 1 or 0. Most of the time I am seeing either 1 or 0. There is no smooth variation from 0 to 1. Right? So waves అనేవి ఇంత కాంపాక్ట్గా ఉన్నప్పుడు మాత్రమే ఏం జరుగుతుంది, the resultant pattern is very short. We'll have sharp zeros and sharp maxima, sharp minima and sharp maxima. If the incoming waves are very sharp, ఇలా ఉన్నాయి. ఇప్పుడు పరిస్థితి ఏంటంటే, when they superimpose with an additional shift అయినప్పుడు ఏం జరుగుతుంది, either you may have, let's say second wave starts from here. ఇప్పుడు ఈ సూపరింపోజిషన్ ఏమవుతుంది, you'll get smooth variations. మనకు ఆ స్మూత్ వేరియేషన్స్ అనేవి వస్తాయి ఎప్పుడంటే when the wavelength is sufficiently large. లార్జ్ వేవ్లెంగ్త్స్ ఉన్నప్పుడు ఏం జరుగుతుంది, మనకు ఇంటర్మీడియట్లో ఉన్నటువంటి కంటిన్యూస్ వేరియేషన్స్ అనేవి మనం క్లియర్గా మానిటర్ చేయడానికి అవుతుంది. When the wavelength is well defined and when you have sharp waves, you won't get that. I mean, all you see is only sharp either 0 or sharp 1. No other possibilities. So all these are ruled out based on this condition. The size of the object must be comparable to wavelength of the light. That is the primary condition. So now we have 3 conditions for this interference pattern. So one is sustainability, condition for formation. ఫార్మేషన్ కి కండిషన్స్ ఏంటంటే, 1, wavelength of the light must be comparable to the size of the objects involved. Another one, 2 sources must be coherent. Coherent అంటే ఏంటంటే, the 2 wave lengths you consider maintain the same frequency throughout the time. What happens if the coherence part is missing? ఏం జరుగుతుందంటే, for some time you have both waves in same phase. For some time the phase relation may change. After some time phase relation may reoccur. So this kind of patterns should not occur. So condition for formation and sustainability. This is the condition for sustainability. Sustainability అంటే ఏంటంటే condition for long lasting. So to maintain the interference pattern for longer times, the two sources must be coherent. Okay. Second one, condition for visibility. Second thing, third one, observation. Okay, so we have somehow formed these interference patterns. అయితే దాన్ని అబ్జర్వ్ చేయాలంటే మనకి ఏం కావాలి? So with a small derivation, the fringe width is given by beta is equal to d lambda by 2d. So beta is equal to d lambda by 2d. So d, capital D, is the distance between source and the screen. 2d is the separation between the two sources. And lambda is the wavelength of the light used. So మనకు ఆ ఫ్రింజ్ ప్యాటర్న్ క్లియర్ గా అబ్జర్వ్ చేయగలగాలి అంటే కండిషన్ ఫర్ అబ్జర్వేషన్ ఇస్ ఫ్రింజ్ విడ్త్ మస్ట్ బి వెరీ లార్జ్. ఎంత ఉండాలండి? సో d మస్ట్ బి వెరీ లార్జ్ and 2d must be, d must be sufficiently large and 2d must be sufficiently small. Then only you will have sufficient width for fringe pattern. So condition for observation is d must be sufficiently large and 2d must be sufficiently small. In this equation, beta is equal to d lambda by 2d. So fringe patterns form అయినాయి. So what we have observed as of now, the fringe patterns are formed and they remain forever. They are long lasting and we are able to observe them with sufficient width. Then the final condition is condition for visibility. Fringe pattern form అయింది, sufficient width తో form అయింది. బట్ అది కనపడాలి అంటే the intensity differences must be so I am defining here V, visibility, condition for visibility as the difference of this I max minus I minimum by I max plus I minimum. Difference of the intensities by sum of the intensities. I max minus I minimum by I max plus I minimum is the condition for visibility. If V is 0, I'll get very short interference patterns. V0 అయితే ఏమవుతుందంటే I'll get 0. So I should have I maximum must be maximum, I minimum must be 0. I max అనేది maximum ఉండాలి some number. So ఇక్కడ ఏమవుతుంది? Here I max is equal to 4a square. I minimum is 0. So in that case what is V? ఈ కేసులో V ఎంత అంటే 4a square minus 0 by 4a square plus a, which is 1. So if V is 1, I'll get best interference pattern. If there is any smooth variations and if both are equal, if I maximum is equal to I minimum, what happens? I mean, both are superimposed, both are merged together. I mean, I cannot distinguish between maxima and minima. So in that case, V will be 0. So if I see I maximum is equal to I minimum, both maxima and minima are visible at with same intensity. So in that case, I should say visibility is 0. Okay, so I have to ensure this I maximum and I minimum difference to be very large. Then only fringe pattern will be clearly visible. Okay. So these are the conditions for interference pattern. First condition is about formation. Second one is about long lasting maintenance of the pattern. 3 and 4 are for user convenience for observation. The last one